Hi, this is Dima Brook from XP.NETWORK, and today we're going to continue our series. This is the third video from the series, where we're going to learn to optimize our Solidity storage. So we're going to write everything using Solidity Assembly called U. During the last video, we learned how to read those variables from a single slot, and today we're going to see how to write those variables without disrupting the storage of its neighbors inside one slot. So first of all, let's see how to simply do it in Solidity. So to do so, let's write a function, set a Solidity. It's going to be inside integer to 156. And let's call it new A. Let's make it external. We won't set any modifiers because this is a testing contract. And let's just say that A equals new A, like so. Right, it wasn't 156, it was 128, like this. Right, so let's quickly do the same for the rest of the functions. So it's going to be B. Let's replace A with B in every position. And now it's not happy because B was 96. Let's do the same for C. Let's replace B with C in every position. And this is supposed to be 16 this time. And let's replace C with D, like this. And the type has to be inside integer 8. Let's quickly compile the contract. Let's deploy it, and let's check that we're able to reset our variables. So this is our slot 0. Let's read it. Here we can see all our variables. So let's set A, let's say to 5, for example. And let's check that this 1 is supposed to change for 5 now. And there we go. Now B is 2. Let's change it to 3, for example. And let's check. Now it became 3. So our C is 3. Let's change it to 16, for example. Let's test. There we go. So this is 16. And we have 4 in position D. So the maximum it can hold is to 155. Let's record it. And there it is. 2 Fs. Signal that this is to 155, the maximum value it can hold. Right. So the next thing we can do is we will do the same but using assembly. Let's start the function. Set A in U will be assigned integer 128. New value. It's going to be external as well. And in order to start, we have to say assembly. And the first thing we have to do here, it's going to be double S. So let's set A, let's say let A equals S load. We're loading our storage variable from the position where A has its slot. Okay. Now what we do is we're going to need a mask. Let mask equals. Okay. And now in order to create a mask, let's look at our slot like this. Let's put it somewhere here close to the mask. Here. And let's see what we actually have to do. So we're now going to combine it with the mask, the slot with the mask. We're going to apply AND to 2 of them. And we remember the rule that if we apply 0 and some value, we will get a 0. If we apply F and some value, we will get the value itself back. So let's make a mask like this. So what we're saying by this mask is clear everything that was in our A variable here and leave everything that was in our other variables. So let's now create a clear equals and mask. First we have to say actually A and then mask. It doesn't matter the order, it's not important here. So the next thing we have to do is we have to shift it. So let's say let shifted equals shift left, and now we have to multiply the offset. So we say multiply A offset, and we have to multiply it by 8 bytes, because this offset tells us the number of bytes, but we need to shift it by the number of bits, so that's what we put here. And then provided we shift this value by this product. Right, so let's say let new value equals OR. So now we have to OR our shifted and clear, like so. And now we have to say s store, so we're storing in our slot, which is a slot, and what we have to store is the new value, like so. So let's go and check whether we did everything correctly, like this. Let's deploy. Right, so this is our slot before we modified it. So here's our function that we just created. So now A equals 1, let's try to set it to 2, like so, and there we see it became 2. Let's try to set it to lots of 2's, and there we go. Our value modified only in the part of A, and all the rest of the slot is intact. Well, now let's do the same for other functions. Let's now replace every occurrence of A with B. Like this. And now what we see is we will have this A, which we'll every time have to replace with another variable. So let's again modify it and just say value, like so. Now because B has a different type, let's replace it here, so that by accident we don't provide a type that we're not able to place here. And the next thing we have to do is we have to modify the mask. So now we actually have to leave A intact, so we will leave all zeros there, but now B has to be removed. So we will place our zeros here in the positions of B. Alright, let's check if everything's okay. Recompile the contract, redeploy it. Let's see. So this is our slot before we modified it. Let's check that we can still set A with U. Okay, A is 2 now, and B was 3, so let's set it to, for example, 5. So we can see that it changed, and there we go, it became 5. Now we can do the same for C, like so. Let's again replace every occurrence of B with C, like this. And we have to change the map. So let's leave F's here. So basically the first 4 have to be F's. The next 4 have to be zeros, and the rest will be F's. Like so. So we're now replacing everything in the position where our C slot resided, and we leave all the rest of the slot intact. Okay, now let's recompile the contract. Let's redeploy it. And let's check that everything works. So here's the function that says set C. So let's check our slot before modification. Our C was 3, so let's try and set it to 5. There we go, it changed to 5. And all the rest are intact. Now let's do the same for the variable D. So let's replace C in every occasion for D, like so. And now let's fix the map. And now let's fix the mask. So let's remove everything related to D, and all the rest from C should stay intact. Let's again remove the contract. Let's recompile it, redeploy, and let's test it again. So our slot before modification looked like this. Now let's set D in U. It was initially 4. Let's try and set it to 5. And there it is, 5. Let's try and set it to its maximum, to 156. And there it is. So let's now set every variable to 156 to see that everything still works, like this. There we go. And finally A. Right. Okay. In fact, it wouldn't be nice to leave the same code written in all those functions. So let's refactor it. Let's create one function that will handle everything, and from each function we'll just provide the parameters. So let's say function, let's make it like this, let's say set slot, like so. We'll have many parameters, so let's move them here. Let's say unsigned integer to 156 because it's more universal, it occupies the entire slot. It's a new value. Right, the next thing is going to be again unsigned integer to 156 slot. This will be the number of the slot. Next thing is going to be bytes 32, which is going to be the mask. The next is going to be unsigned integer 8, which will be the offset. Basically, the maximum offset is 32, which will be the entire slot. So this unsigned integer should be able to hold it without any problems. And we also have to say that it's internal. So it can be only be called from inside the function. And let's do this. Let's move this entire thing from the function here. We'll use it as a template. Right, we don't need the mask anymore. Let's save this mask here for now, because we already had it here. Let's save it here. Right, let's remove it, because we already have the mask coming from there. Right, so let's remove the offset, it will just be the offset. Let's remove D slot because it will just be the slot coming from here. Same thing here. And it seems like all the values are there and we're good to go. So now let's try and call this function from here. Set slot like this. Right. So the first parameter will be the new value. But let's wrap it in unsigned integer to 156, like so. The next value is the slot number. Well, we remember it was 0. It's the only slot we have. The next thing is the mask. So now let's wrap this in bytes 32, like so. Let's cut it from here, place it here. Okay, we don't need it anymore. And the last parameter that we needed is the offset. Alright, so offset is how much we have to move here. So every 2 digits digits represent one slot. So we have 32 slots all in all. So we have 1, 2. So 32 minus 2 gives us 30. So the shift should be 30, and we have to add a semicolon here. And let's test it in action. So let's go and compile our contract here. Let's deploy it, and let's see if we are still able to update our storage. Right, so it was D, it was initially 4. Let's set it to 5, for example, like so, and there we go. Right, so now let's go and do the same here. Let's copy this implementation, this call here. But now I just have to replace this with this mask, and the offset now is, let's look, 1, 2, 3, 4. So 32 minus 4 gives us 28, and we can now safely remove the rest. As you see, our code became smaller, and we're not repeating ourselves because all the logic is here. Let's now do the same here, like so. Right, let's replace the mask like this. Now again, we have 32 slots all in all, and this we should offset it by A. So A occupies exactly half, which gives us 16. Like this. So let's remove this, and let's also set it for A. Right, let's call it here. Let's replace the mask. It's gonna be 0 offset because A begins from the very beginning. And now we can clear all this. Let us now remove the old contract, recompile it, redeploy, and let's test again. And this was our initial slot before we modified it. So D was 4, let's make it 5. There it is. C was 3, let's make it 8, for example. And there it is. B was 2, let's make it 7, for example. And 2 became 7. And A was 1, let's make it, let's say 16. And there it is, 16. So this looks much neater, and we now understand why we needed all those masks. And now we also understood the concept of the offset, what exactly this offset was doing. So in this video, we were able to learn how to set our variables while they reside inside a single slot without modifying the other variables from the same slot. And we were doing it using assembly, otherwise known as YUL. Thank you for watching. Don't forget to subscribe not to miss our future videos, and see you next week. Bye.